So this is a follow-up video to the video where we looked at using the digital research assembler and loader for CPM 2.2. And what we're going to move on here now is using Aztec C under CPM and kind of how to work with that. So I got the beginning of a C program here that kind of does what we did with the assembly language program. Can read a character typed on one terminal session and write it to the other one, or can read a character here and type it to this one. This is TTY0 on my Altair. It just happens to be on COM5 on my PC. And this is TTY1, which happens to be on COM1. So here's kind of the beginning of the C program we've written. Very much like we had in the assembly program here, these equates. For the C program, we have # defines. So, SIO1 control is on port 10, DAT's on port 11, SIO2 controls on port 12 and port 13. We have that same reset command that we looked at in the previous video right here. Setting the port to 8 bits, no parity, 1 stop. We're going to look for an escape character to exit the loop, and in this case we've added this char ready, which if we see a 3 as the status on the UART, we know there's a character ready. We've got a little main loop set up here. We've got a variable to store status 1 in for UART1, for data 1 for UART1, status for UART2, and data for UART2. The equivalent of this assembly code is really these two lines here. So Aztec C for CPM includes an in and out function. And out's just what it sounds like. Out on this port, this value. Out on this port, this value. So this sends that SIO reset to UART1 and UART2. We then wanted to set them to 8N1 and the same kind of thing out to UART1, that byte, now to UART2, that byte. So we've reset the two UARTs and we set them for 8N1. I then needed a little loop here because I didn't know what this value was going to actually be, and I was too lazy to go look up the data sheet for the UART. So I wrote this little loop here that basically outputs kind of a header here, so we know what's going on, and goes into this little loop and gets the status for SIO1, and any data that happens to be in the SIO1 register gets the status for 2 and any data for 2, and then prints out these 4 values in hex. So, and that's what this is here, is 0 filled, 2 characters wide, hex, integer. Oh, interesting, I'm missing the 0 fill there. Why can't I get the cursor up there? Oh, it is there. So this was just a typo I had before. So 0 filled, 2 characters wide. So that should format status data. Oh, typos down here. Where is my cursor? That's really weird. Always got to be something. Well, I'm going to close down Notepad and reopen it. It'll open up with the same files it had before, and see if we get back a cursor, and we do now. Status 1 and status 2. I renamed these variables to the S's up here from C just because I thought it was a little bit clearer. So again, we're going to output the status for UART1, the data for UART1, the status for UART2, the data for UART2, and this is going to loop until on UART2. This has been modified because I now know this value from running this previously, that there's a character. Basically it's saying is there's not a character ready on 2. Wow, S2 equals. It's going to loop while this doesn't have a character ready, or it hasn't been the exit character, and we'll look at why that is here in a second. But as piss poor as that was, there's an explanation. So let's turn on the Altair. Let's put in our Aztec C media I created. We'll go ahead and start the machine, and we're in CPM. So this is really a minimal CPM install on this floppy. It's got the digital research line editor. It's got the Aztec C compiler, the Aztec C assembler, the Aztec linker. This is the C library. This C library is where functions like printf and these in and out functions live. And actually, a program I did earlier, this hello world.c, and let's go ahead and compile it again. So let's take a quick look at hello world.c, type it out. And this is just a simple little C program, loops 256 times, outputs the string hello world, Aztec C welcomes you, and gives you the pass number. And this has been previously, if I can find the files here. So there's hello world.c, hello world.object, the hello world.com. So let's go ahead and go through the loop and compile this. So we're going to compile hello world.c. It'll assume the extension. As you can see, it's not super fast on here. And the compiler responded, they said, hey, I'm version 1.06D, I'm for the 8080. This produced an assembly output file. So there's a fresh copy of hw.asm. There's the assembly code that was turned into. There's quite a bit of stuff in here. Quite a bit of stuff here, and we can go through and analyze this, but we won't. It's got a few labels in here. It's got a string table down here, and various other stuff. Well, we've got that assembly file. Let's go ahead and assemble it now. So the C compiler produced an assembly output. It's AS, isn't it? AS, hello world. That's taking that ASM file as an input. It's going to output an object file. So as you can see, the workflow for C is different. And this gave us this hw.object file. So that's a file waiting to be linked. We're then going to link hardware.object with c.lib. And so what this is going to do is it's going to look in this hardware object file and say, hey, it needs the printf, it needs the in, it needs the out function. Extract those functions from the C library and produce for us a COM file. So this is very old school. It's K&RC syntax, and it's very, the very old workflow I'm used to, where you compile C code, you assemble the assembly output, you link the various objects that you need to get your executable. And let this finish linking here. And then you end up with an executable that you can run, debug, etc. So again, it's told us it's going to load at address 0100 hex, the standard CPM address, where the data is, just various bits of information about the program itself. As you could see from that assembly file, it's not nearly as tight as this was, partly because it's got to deal with libraries and other things. Let it keep linking here. You should be able to hear the floppy drive back there accessing away. That's an 8-inch 330K floppy drive. And now we can run, well, it's got to have input here. And I just typed in the wrong window again. I like to do that a lot. That's just kind of how I roll. And we'll go ahead and run the newly produced COM file. And this is going to take a bit because it's got to loop 256 times. I have no way of breaking out of this. It's not, trapping on Control-C and getting out. And it's run all 256 loops. 256 because it actually started all the way back up here at 0. So that's why there's 256 total iterations. So let's go ahead and create 2SIOPP.C. I'm using the Digital Research Editor, but I'm not going to use it as their editor just because it's a major pain. It's a line editor, and I'm lazy. We're going to do a lowercase I to insert allowing lowercase characters. We're going to paste in here what we just copied from over here. For the serial port setup here in TerraTerm, I think we can look at this. No, I guess we can't. Well, it's running. I've got a 25 millisecond delay after every character it sends and a 100 millisecond delay at the end of every line to give the ED program time to actually grab the characters and process. You can see here I've got a lot of comments, and I'm using more white space than I need to, especially up here where I've got the end comments lined up. I've got a lot of white space in here, and that's going to occupy bytes on disk. The preprocessor and the compiler will, of course, remove all those comments. So the source has been sent up. We do a Control-Z to say we're at the end of what we're inputting. We do an E to exit. That edit session now gets written out to disk. 2SIOPP. Let's go ahead and compile it, see if we get a clean compile. I don't know what would be worse in a large program, trying to use the ED editor over here to open lines and edit lines and go through that entire workflow, or to do what I'm doing here, just edit it in a better editor. It is cheating. Paste it in and go. I've gotten spoiled over the years. I like color syntax highlighting. The comments are all in green. Well, that did compile. That's a good sign. 2SIOPP. This will now assemble the 2SIOPP.asm file that the CC command above kicked out. Now we need to link it to SIOPP's object file with the C library. You can imagine how painful this would have been back in the day trying to write, large programs. Hard drives would, of course, made this quicker and easier. 2SIOPP. Let's go ahead and run what we just wrote. And there it is. So what it's outputting, it's got an extra character output here. So it's outputting, this is what it's finding for the status for UART1, and the last thing that was typed into it was the return I typed right here. The status for C2 and the data for C2, and why that's giving me 115, I don't really know. That should have been 2 character wide hex, so it should never be wider than 2 bytes. Let's type something down here. That's actually coming out as decimal, I think. 02 XD. If I type an F up in this one, those are coming out as decimal. Why are those? See, uppercase A is a 65. Yeah, these are being displayed as decimal and not hex, and I don't know why that is. So what if you watch here, the 02 there, you may see it flash to a 03 here. When I hit a character down here, I see it flash. That 03 is when it's saying, hey, there's a new character in the buffer. So what you're seeing here is the value for the last character typed is always in that data register in the UART. If we come up here and type in, you should see this one here jump to a 3, and it is. I'm really confused. Is it X for hex down here and not H? But I should be able to come in here and hit escape. Actually, I'm only allowing escape to get us out from TTY1 down here. Escape should exit and get us back out, and it did. And I'm back in that funky state where if you've watched all my videos where you see a Terra term get confused. I'm going to close it out here, and I'm going to rerun Terra term. And that'll get things back in sync where it's acting correctly. So, I don't remember. Is it X for hex down here? I need to fix that. I shouldn't need that space off the end there. I don't know why that's there. And let's change this to be status 1 and status 2. To SIOPP dot C. Actually, no. What I want to do is an erase to SIOPP dot. And we're going to start the entire loop from scratch. Save it out. Compile to SIOPP. Notice I'm not giving it an extension here. I don't need to. It assumes a .c extension. To SIOPP. We'll assemble the ASM file it kicked out. Link to SIO. Boy, I'm trying to think here, and that's always a bad thing. Object file to c.lib. And when I create the executable link, link to SIOPP.object to c.lib. SIOPP. Character is going to be, of course, 8 bits wide. Don't need the D's. Wow, it's been a long time. So we can see here, let's come up here and type a capital A, which should give me 41, and it did, which would be 65 decimal. So that's correct. Come down here and type a lowercase z. 7A seems correct. We should see the 02 jump to a 03 here, and we do. Didn't need the D's, so I don't know if syntactically this is different from what I'm used to. It appears to be casting these correctly from an 8-bit char value to, it's expecting a 16-bit integer here. It seems to be casting them okay. So we know this is going to work. Taking the D's out will make the D's go away. Escape down here and exit. So as you can see, this is rather painful. Rather than take you through the entire loop again, I will get this input to the machine compiled and linked, and we'll look at it working, and then we'll extend it to actually do the type back and forth stuff. So I tweaked the code here to get to a point where this is working. Using X here to dump these variables as hex values rather than decimal. And this now works. Let's go ahead and run it just to demonstrate. So it's telling us that the status bytes are set to 2s. The last character that was entered up here was when I hit the carriage return here on the end, and that is the 0D. And down here, the last character I actually typed was an escape, and that's what we're seeing here is the 1B. The way this code is written is it says, I need to see a byte sent, which is what will happen here, and the exit character in order to exit. So this is just going to sit here and loop. Another thing just to comment on is this is a /R, which is a return. So when I printed out this line here to kind of give us a header, I used a /N, which is new line. New line returns the cursor at the beginning of the line and moves down a line. /R just says return the cursor and type over the top, which is what you can see is going on here. So in this window, if I hit, say, a capital A, we should see this flash very quickly to 3. Hopefully it'll get captured here, and we'll see this change to a 41 hex. And I'll keep hitting it here so you can see the 2 changes to a 3 for the 1 loop, because there was a fresh character sent to the buffer. And if we come down to this window and type in again capital A, we'll see the same thing here happen. This will flash to a 2 for 1 cycle, and this will change to a 41. If we hit a lowercase z down here, again we'll see it flash to a 3, and we'll see the 7A, which is the ASCII representation of a lowercase z. Come back to this window, and we'll see the same thing. So this is now working as expected, and it's telling me that during that brief moment when there's a character in the buffer, that a status changes to a 3. Again, we'll come down here and watch this byte right here, and it flashes over to a 3. Whether you can see it or not on camera, it's hard to say. I can hit an escape down here and get out. And once again, the terminal is screwed up here, and I don't know why that happens. I'm going to go ahead and exit TerraTerm. I'm going to restart it. I'm actually going to tweak this a little bit. We're going to add back my delays here of 25 and 100 milliseconds. And I'm going to go ahead and save this setup. It's just the default setup, TerraTerm.ini. So if I have to do this again, it'll open up in the correct position and with those delays put in. So how to convert this? So we have the status for the UART1. So let's go ahead and add an if S1 equals care ready. And remember, care ready we defined up here as that 3. We're going to read from D1, and then we're going to do an out to SIO2's data. The byte we read is the data, and we're going to convert this one the same way. We're going to do an if status 2 typing that a little bit wrong. It's a little clearer this way. If status 2 equals care ready, and then we're going to do an out to SIO1's data. What we just read in as data 2. I'm going to comment out these 2 lines since they're no longer needed. This is getting us closer to what that assembly language program in the previous video did. And a loop until there's been a fresh escape type down here on terminal 2. So I'm going to leave it that way. In the assembly language program, you can hit escape in either terminal to exit. I'm just going to leave this way for now. So that should get us those 2 loops that kind of represented really this block of code right here, really minus that for terminal 1. Essentially includes this for terminal 2 by what's going on down here. So loop all that conditions true. If not, fall down. It exits main, and that, in the case of the C code, will do the warm boot again. So let's see what that gets us. So what have I got wrong? So it caught an error at line 34. That doesn't necessarily mean it is CHRRDY. So this is where it gets really interesting. Oh, line 43. So I had the wrong line number there. So what have I done wrong here? Don't know if you see it here or not. It is SIO2 capital DAT. I have lowercase. So this gets back to the original world of C programming, where it's pointing right here, saying there's been an error in line 43. It actually gave us a hint what it was right here. But the line it came back with, so it did say on line 43, so actually this was a little more useful. So it caught the fact that SIO1 DAT, all lowercase, isn't defined. So let's go ahead and do the whole workflow again. Compiling is the act of, oh, it still doesn't like something. Oh. What is the V here? Oh, that's just got to be a typo. That should be... Wow, that's just a typo. I've managed to probably have it highlighted and typed a V accidentally in the window. So, sadly, I didn't catch that previously. So as I was starting to say before, compiling is the act of compiling C source code into assembly code. We're then assembling that outputted assembly code to an object file, and then we're linking that object file with the required libraries to get our executable. So workflow's got more steps than it did in direct assembly. We're now going to assemble to SIOPP, and that will take the .asm file the compiler emitted and assemble it, and this will emit the object file the linker then needs. Now we can link to SIOPP.object to the C library. Remember again, the C library has the code to implement printf and in and out. So to SIOPP, let's run it. And if we type a capital A here, we should get a capital A down there. And we do, and if we come down here, make this the active window and do a lowercase b, B's get set up the other side. And you can see here there's no local echo. When I'm working down here, I have no idea what I'm typing. It's all being sent up here. Oh, I've actually got the top window active. Okay, that's interesting. Huh. In this case, it's no longer echoing back up. I don't know why. Let's hit escape down here and see if we can get out. Obviously, something is wrong here because this is falling apart pretty quickly. In this case, I don't have interrupts enabled. There's no Control C in the hardware to produce an interrupt to actually get me warm booted back. So I'm going to have to warm boot from the front panel. Obviously, we have a bug. PP, no idea what that bug is. It was interesting. It attempted to work. You can see me typing in up here, the capital A's and appearing down here. If we type in down here, capital B's, they appear up above. Type back in up here. Now it's working as I'd expect it to, so I have no idea what happened there. It escaped down here and it exits back out. So that's a pretty long, DIR. That's pretty long video, I think, for just trying to get some C code to compile, especially C code that isn't particularly useful. Really need to pull that out down here. It adds confusion. It is what it is, so I'm going to call that kind of our example of using Aztec C to do something, doing something a little bit odd in this case. I think I'll call this video done, and we'll talk soon.